We're asked to find the Maclaurin series for f of x equals 4 times the quantity 1 minus x to the power of negative 2. Assume that f of x has a power series expansion and that the remainder, Rn of x, approaches 0. Then determine the radius of convergence. Again, remember that the Maclaurin series is a Taylor series centered at x equals 0. If we go back to the formula for the Taylor series, this top formula is the one given by most textbooks, but you may find the formula below, which is equivalent, easier to remember. Either way, if we set c equal to 0, we have the Maclaurin series, which is shown here at the bottom of the screen. Now we want to find the first several terms of the Maclaurin polynomial to use to then write the Maclaurin series. Let's find the first 4 terms, which requires we find the first 3 derivatives of the given function. So beginning with the given function, which is equivalent to 4 divided by the square of 1 minus x, f prime of x is equal to the derivative of 4 times the quantity 1 minus x to the power of negative 2, which is negative 8, times 1 minus x to the negative 3, times the derivative of 1 minus x, which is negative 1. Notice because we have a composite function, we do have to apply the chain rule. F prime of x simplifies to 8 divided by the cube of 1 minus x. The second derivative is the derivative of 8 times the quantity 1 minus x to the power of negative 3, which is negative 24 times the quantity 1 minus x to the power of negative 4 times negative 1, or 24 divided by the fourth power of 1 minus x. The third derivative equals the derivative of 24 times the quantity 1 minus x to the power of negative 4, which is negative 96 times the quantity 1 minus x to the power of negative 5 times negative 1, which simplifies to 96 divided by the fifth power of 1 minus x. And now again, because we're looking for the Maclaurin series, which is centered at x equals 0, we now evaluate each of these functions at x equals 0. F of 0 equals 4, f prime of 0 equals 8, f double prime of 0 equals 24, and f triple prime of 0 equals 96. And now starting with the Maclaurin polynomial, we now substitute in the function values, which gives us the Maclaurin polynomial of t sub n of x equals 4 plus 8x plus 24 divided by 2 factorial x squared plus 96 divided by 3 factorial x cubed. Now let's simplify the fractions with the factorials. 2 factorial equals 2, 24 divided by 2 is 12, and 3 factorial equals 6, 96 divided by 6 is 16. We now have the Maclaurin polynomial of t sub n of x equals 4 plus 8x plus 12x squared plus 16x cubed, and so on. Hopefully we have enough terms to recognize the pattern to write the Maclaurin series. Notice we have 4, 8, 12, 16, and so on, which would form an arithmetic sequence. So if we start at n equals 0, we could use the formula 4n plus 4 for the coefficients, and therefore we can write the Maclaurin series as the sum from n equals 0 to infinity of 4n plus 4 times x to the power of n. Notice when x is 0, we do have 4 times x to the 0, which is 4. When n is 1, we have 8 times x to the first, or 8x. When n is 2, we have 12x squared, and so on. If we did start the index at n equals 1, we could also express the Maclaurin series as the sum from n equals 1 to infinity of 4n times x to the power of n minus 1. Let's go ahead and use the series where n starts at 0 and now determine the radius of convergence. Let's do this on the next slide. To determine the radius of convergence, we will apply the ratio test, which indicates we'll determine the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n, which must be less than 1 for the series to converge. A sub 1 is the given formula, and here we have a sub n plus 1, which simplifies to 4n plus 8 times x to the power of n plus 1. And now let's set up the limit. Again, we have the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. And now let's simplify. X to the power of n plus 1 divided by x to the power of n simplifies to 1 factor of x, giving us the limit as n approaches infinity of the absolute value of x times the quantity 4n plus 8 divided by the quantity 4n plus 4. Notice 4n plus 8 and 4n plus 4 are both degree 1, and therefore as n approaches infinity, the n part approaches the ratio of the leading coefficients, which is 4 divided by 4 or 1, the limit equals the absolute value of x, which if the series converges must be less than 1, indicating the radius of convergence equals 1. And again, this is due to applying the ratio test. Before we go, I do want to mention, we now know that the series converges on the open interval from -1 to +1. However, if we were asked to find the interval of convergence, we would need to test the endpoints of x equals -1 and x equals 1 and determine if the series converges or not at those values. Before we go, let's look at the graph of the original function in the first several terms of the Maclauring series. In red, we have the graph of the given function. We were asked to find the Maclaurin series centered at x equals 0. Notice 0, f of 0 is the point 0, 4. Now let's look at the graph of the degree 3 Maclaurin polynomial, which we use to find the Maclaurin series. Notice around the point of 0, -4, the Maclaurin series is a very good approximation for the given function. I hope you found this helpful.